I thought this was a really good place to start because, as you said in the intro, I'm now looking at the gas industry, and I thought, what's the striking number I can throw at people here to make everybody realise how important gas is today, but actually also how much of a change we're going to have to go through if we want to hit net zero. And I guess the key facts are on this slide. The gas transmission network that I work for today carries around 3/4 of the energy we use in the UK today. 85% of you on the call, by average, will have a gas boiler in your home. And that gas boiler will put out anywhere between 3 and 5 tonnes of carbon per annum. Now, if we're going to hit net zero, we've got to come up with new solutions for particularly the heat in homes. That accounts today for about 38% of use. We've got to come up with new ways of generating power. Today it's around 39%, but we can see wind and solar starting to kick in heavily in the UK. And around 23% of the use today is by industry. So we've got to look at ways in which we can decarbonise some of those very difficult sectors, particularly heavy industry. So, on the basis that gas today is producing around 50% of our emissions, we've got a lot to do over the next few years. And if you can just take us on to the next slide, please, Phil. There have been a number of publications. In November, we had the government 10-point plan come out. Hydrogen was number 2 on that list, and hydrogen was actually connected with 3 or 4 of the other points in association with that 10-point plan. So I'm jumping here straight into the crux of it. Hydrogen as a decarbonised gas is an option. Obviously, when we burn hydrogen, all we get is water at the back end. So it's a great fuel from that point of view. It's not without its challenges on how we might produce it. But as the government produced in their energy white paper, there is a clear government strategy now, which has been supported by the devolved governments in Scotland and in Wales. They're all pushing towards development of a hydrogen economy. So I'm going to try and give you a bit of an overview of where hydrogen might fit in. Its application in a number of the sectors. We're going to have a bit of a debate around some of the colours of hydrogen, because there's a good conversation to have there. And then I'm going to talk about some of the projects that we've actually got underway at National Grid to really demonstrate that hydrogen is a viable solution, and it will start to present some options for the future. So just move me on to the next slide, please, Phil. I've put this in because I wanted to illustrate that this is not just the UK thinking that hydrogen is a way to go. This is a global map of countries that are really supporting the whole hydrogen agenda. And what I want to do is just call out some of the really big numbers that are on this screen. Particularly, I'll pick on Germany. Funding of €9 billion is being put into hydrogen right now. They've got a goal of 5 gigawatts of production to be up and running by 2030. France, 7.2 billion by 2030 and 6.5 gigawatts. Interestingly, here in the UK at the moment, we do have a target. The UK has said it wants 5 gigawatts by 2030. Scotland has also said it wants 5 gigawatts by 2030. Now, I don't know at this point, is it 5 plus 5? Or is it a factor of the two? We're expecting our hydrogen strategy to be published in the next few months. And then by next few months, I think it's before the end of this half of the year. So in June, July, probably before the summer recess. So I'm expecting a lot more meat on the bones around the goals that government are going to give us. It's going to be a build on that 10-point plan, a build on the energy white paper that we've already seen. And it's going to start getting into what do the business models need to look like behind this. So let's get back to basics. What might be the role of hydrogen in net zero? And if we can animate to the next slide, please, Phil. There's a few bits of animation coming up now. And you'll see at the bottom, there's a blue dot and there's a green dot. And that's because there are 2 primary colours of hydrogen we talk about. Blue hydrogen is produced from the reformation of natural gas, and you capture the carbon and you sequester the carbon, generally under the sea. The other way of producing it is through electrolysis of water, using ideally renewable electricity generation, and you electrolyze to a very pure green hydrogen, 100% purity. If we use carbon capture, we're generally getting around 92 to 95% of the accepted carbon capture levels in hydrogen. So if you just animate the first set of dots for me, please, Phil. At the moment, we've got a number of industrial schemes underway. We've got a number of industrial clusters, they're highlighted. And we've got a number of blue hydrogen production schemes underway where they're going to be capturing the carbon and sequestering that. You'll notice that all of those dots are around the industrial clusters that sit within the UK. So the message here is blue hydrogen production. It's not perfect in the sense that it gets us to 92 to 95% of the way from a capture point of view, but it does allow us to start decarbonising very quickly at scale in those industrial clusters. And because it's pinpointed, it's at a certain point of locations, you're not so reliant on a network that sits around it. In parallel to that, if you just animate, please, Phil, we've got green hydrogen production. Now, at the moment, we've got very little in the way of green hydrogen production. What green hydrogen production we've got is largely used for transport purposes. And you're probably saying, where can I actually go and fill up with hydrogen in the UK? And there are only about 16 places where there is actually a hydrogen filling station in the UK right now. I've shown an HGV on the screen there. That's generally thought to be the area that we probably want to focus green hydrogen first. There are already hydrogen buses running along the South Bank in London. There's hydrogen buses up in Aberdeen. Bin lorries in Birmingham will start going towards hydrogen very soon. And Tyseley is the latest hydrogen filling station to actually open. And that's going to be the one location that I can go and fill up our hydrogen car, because we've now got 2 hydrogen cars in National Grid, purely as demonstration. I personally don't think hydrogen cars is probably going to be the way to go. It's going to be the bigger vehicles, the SUVs, the minibuses, maybe taxis, but particularly HGVs that I think green hydrogen starts to fit in. And it's not really until we get scale of both of these technologies that we can start really thinking about what we might do about the heat equation for our homes. If you just animate me again, please, Phil. Actually, the boiler in your home really doesn't mind, if it was a hydrogen boiler, what colour of hydrogen it is. There are actually other colours of hydrogen, I should point out. You'll hear of pink hydrogen referred to, you'll hear of cyan hydrogen. There's different ways of actually manufacturing that are emerging, but the blue and green are the big ones that people accept, likely to make the biggest difference. So in your home, if you were able to have a hydrogen boiler, we could actually start providing from either colour overall. Over time, we think what will happen is we're going to be able to start blending hydrogen into a network, and up to 20%, we can actually do that with the boiler you've got in your home today. At Keele University, a trial has just finished where they've been blending up to 20% hydrogen and nobody noticed any difference. So take that as a success, nobody noticed. Later on this year in Winlayton, up in the northeast, a whole village is going to be receiving hydrogen at a 20% blend. So these tests and these projects are already underway. Personally, I think blue hydrogen is probably a transitional technology, and longer term, green hydrogen is the way we want to go. If you've got lots of offshore wind generation in the North Sea, produce your hydrogen, put it into store, and it's a completely renewable approach. So I think that's probably the way we would go. And in the home, if you just animate again, Phil, I think over time you would actually see green hydrogen start to dominate. And then in theory, if you animate again, please, Phil, you'll be able to see industry probably adopting green as well. So that's my personal view. That's not a National Grid view. It's where I think it would likely go. And that's me thinking more from an environmental perspective and more realistic overall. So having thought about where hydrogen might be produced and where the main users might be, how do we start moving it around? If you can move me on to the next slide, please, Phil. The gas networks that we've got today have been constructed over many, many years. The oldest parts of the national transmission network were actually built around 50 years ago. Some of the distribution networks much, much older, but there's a lot of replacement gone on in the distribution world, and about 70% of distribution today is replaced with the yellow plastic pipes that you see. So essentially, we've got a leak-free network built to very, very professional standards. And from a hydrogen point of view, hydrogen into distribution is very, very likely, and the network's able to cope with it. A little bit more challenging from a transmission perspective, because our transmission network is steel. And hydrogen and steel, if you're a chemical engineer, people will immediately say hydrogen embrittlement is a risk. And this is just a process where the steel becomes more brittle based on the hydrogen atom getting into the metal lattice work and starting to enhance the crack process. That's very much a phenomena that we see in chemical processing works and so on. But if you go and talk to a hydrogen transmission company, and there are some around the world, they don't see it as a phenomena. So the biggest challenge I've got right now is really demonstrating, could the asset that we've got today, the asset that the transmission network is worth around £6.5 billion. There's a huge investment being taken place in that. Is it actually able to carry hydrogen? And we've done a degree of work around asset readiness, as you can see on the right-hand side. I don't expect you to be able to read the individual lines there, but it's breaking our network down into its individual components. So pipe fittings, valves, heat exchangers and the like. And it's just giving us an idea there on a red, amber, green display, how ready are the assets? And in many cases, it's green, it's good. In a number of cases, we've got a lot more research to do. And ultimately, what that comes down to is it's really safety. And that's highlighted on our next slide. Pretty much everything I'm focused on at the moment is about demonstrating that we could do a transition safely. We operate one of the world's best gas networks in the UK. Our safety record is top notch. It's obviously a challenge if we want to put in and change the format of the gas. Hydrogen is a different gas. It has different properties, but fundamentally it's still a gas that we've got to move from A to B. So I'm very focused at the moment on looking at the material compatibility. It's building up the evidence. It's gathering all of the data, but it's more than that. It's also working out how we might operate this network. If you want to start blending hydrogen into the network, you've got to understand where it's going, who's receiving it. It has a different calorific value, so the energy level arriving at people's homes is going to be different. We've got to work out how do we make sure that the bill payer pays for an appropriate level of energy. So there's a degree of complexity around blending the gas and moving it around. And akin in the water sector would be very much water quality. How do you maintain that water quality and understand what's going where? And we've got to be able to do exactly the same on the gas side of the business if we start going down the hydrogen route. There's a number of things we can do to start mitigating against that. And I've got a big project called Future Grid, which we'll talk about in a moment. But a lot of this is around acquiring the data. And I want to really stress the collaboration. We are working in an environment where I think the UK gas industry is probably collaborating more than it's ever collaborated, both in the UK and abroad, because there's so many companies all trying to do the same thing. And we're all focused on this safety aspect. And in the world of safety, you want to be able to share as much information as you can, because ultimately we are managing a risk-based asset. And that comes first and foremost. So let's start having a quick look at Future Grid. And if we can move on to the next slide, please, Phil. And there's a few bits of animation, so if you can just bring them up so the whole screen's up, please. That's it. Thanks. So Future Grid is a project that we've just received funding for from Ofgem, our regulator. We got the funding just before Christmas, and it's almost £13 million worth of work. And we've just put the first spades in the ground over the last few weeks to start developing this. On one site up in the north of England, and it's at DNVGL's test site up at Spade Adam. Spade Adam is actually an RAF base if you go on the maps. It's a reconnaissance base. It's up in the Cumbrian Hills, just north of Hadrian's Wall, south of the Scottish border. It's in the middle of nowhere. On one site, we have now in production a transmission network connecting with a distribution network, connecting with what is called High Street. And High Street are some hydrogen houses that have been used for the last couple of years. So I'm focused on Future Grid, which is the testing of the transmission facility. H21 is Northern Gas Networks project that is proving the distribution aspects, and High Street has been built by DNV to do some work with bays to prove the safety in the home. So there's a number of partners on this particular project that is coming together to build this beach to meter, we refer to it as, test facility up at Spade Adam. Now let's try and bring it alive a bit more, because I think a picture says 1,000 words. So Phil, if you can move me on to the next slide, please. This is High Street. That could be a set of terraced homes anywhere in the UK. The fact is these have been custom built. They are standard homes, but they've been heavily instrumented. They've also been configured in a different way. So you see the block store on the right-hand side of the front one here. There's more of a garage at the end on the other one. One of them's got a cellar, one of them's got a loft conversion. So they've all been configured slightly differently, because fundamentally we've been reproving all of the gas testing processes that were done back in the 60s and 70s to demonstrate that natural gas was safe to bring into the home. There's a certain irony here, because we were replacing town's gas. Town's gas was produced more locally, probably from coal, and 50% of town's gas was hydrogen. So we went through a massive testing program in the 60s and 70s to demonstrate that natural gas was safe for use in the home, having used it for 150 years. We're now repeating that same test program to prove that we can safely put hydrogen back into our homes. Certain irony there. But let me get back to High Street. This is what it looks like from the marketing picture. If you could just go to the next slide, please, Phil. That's what it really looks like. And look at the countryside around it. This is a test base. It's very much in the middle of nowhere. I was actually up there a couple of weeks ago, and this whole facility has been built out in much, much more detail now. Phil, if you can go to the next slide, please. I'm going to take you up into one of the houses, and what we've got within those houses running already are hydrogen boilers. So it's tanker supplied at the moment, but those homes have got hydrogen feeds into them. That is a 100% hydrogen boiler. It's manufactured by Worcester Bosch, and many of you will have a Worcester Bosch boiler in your home. You may have one from Baxi, and Baxi have also got one of their boilers in the home already up and demonstrating. What they're working on next is what's called a fully hydrogen ready boiler, and actually that boiler will have twin heads in it. So it'll actually be able to run on natural gas up to a blend, and then you'll be able to flick the burn head when a conversion to 100% hydrogen comes through. And that's very much on the process of like the digital ready TV rollout that we saw many, many years ago. So that's the technology they're working on at the moment that is already sitting within these houses from a test point of view. But in the near future, you're actually going to be able to visit some real hydrogen homes. Up in Gateshead, there are 2 houses about to be opened. You'll be able to go into them, and they're heated by hydrogen. The cooker is running on hydrogen. The gas fire will be running on hydrogen, and they're going to be open for demonstration purposes. There's also going to be a demonstration, I'll call it a trailer, but ahead of COP26 later on this year, Bays are going to have a demonstration facility. So I'm hoping to get that demonstration facility to the Midlands, probably at Warwick at our head office. If and when I can manage to actually sort that out, if you guys are interested, I will set that invite out and we'll get that in place. So let's just move on then. I'm going to take you up into a drone picture now on the next slide. And it gives you now an idea of the size of the facility we're building. There's High Street in the middle. H21 is the distribution network. So all of the yellow pipe that you're used to seeing will sit in that green area. There's now over 1 kilometre of pipe in that green shaded area that's been in, and I was walking around it just a couple of weeks ago. The high pressure gas reservoir in that shaded yellow area is also in. We're using some transmission asset for that. It's 60 odd meters long, 4 foot in diameter. It's going to be running at 80 bar in pressure. And then the future grid facility is going to be running around this horseshoe area, first of all at the top and then down the side. So what I'm intending to do for the transmission network is I'm going to be decommissioning some assets from around the UK, and I'm going to bring them into this test facility, and we're going to build them up into a test loop effectively. And from that test loop, we'll run transmission. It'll feed into H21, the distribution network, and then it'll feed down into the high street homes at the bottom. So let's try and bring that alive a little bit. Next slide, please, Phil. And it's very simple, really. It's a loop. Anybody could build one of these loops if you had transmission asset. Now, just to give you an idea, all of the transmission network is either 900 millimeter pipe or 1200 millimeter pipe. So it's large scale stuff we're dealing with here. In order to demonstrate this accurately, we've got to bring in a full entry point. If you just bring up the animation, Phil, I thought I'd try and show you in pictures what this starts to look like. This is an entire compound. You've got slam shut valves, you've got filters, you've got meters, you've got valves, you've got pig traps. Now, a pig in the gas industry is a pipeline inspection gauge, effectively known as the pig. It's used for inspection purposes on the inside of our pipes. So one of the luxuries we have in our transmission networks is to be able to look at the inside periodically every few years as to what's actually going on. So we'll have a full entry point. Now, Phil, if you can just cycle me through the animations, we're going to bring in block valves. We're going to bring in pipelines. If you just animate again. Now, that piece of pipe was actually pulled out just a few weeks ago. The high-speed rail link from London to Birmingham is requiring us to divert a number of our assets. So we've taken care of that. That pipe's just come out. I can't remember exactly where it was now, somewhere in the Midlands area, on the run into Birmingham. And then finally, Phil, if you can just go to the final exit point. That exit point we took apart just a few weeks ago. It took us best part of a week to dismantle everything. Just to give you an idea of the size of it, it took 11 heavy goods vehicle movements to pull all of that equipment up to the site. We've taken all of the kiosks, we've taken all of the control buildings as well as part of this facility. So this isn't a small piece of work. It's going to take us about 12 months to rebuild this test loop, and then we can start actually doing the actual test of what we can do with hydrogen. So if we can go on to the next slide, please, Phil. Now, where we're going to start is 2% hydrogen in blend. That's very, very low. We want to build up then to 20%, which, as I said earlier, is the level of hydrogen you could probably run into your boiler in your home today without any notice or any problems. But because hydrogen only has a third of the calorific value of methane and natural gas, the carbon benefit is a third. So actually, if you put 20% hydrogen into your natural gas, you're only getting a 6 to 7% carbon benefit, which is useful, but it's not a full solution. So really, we've got to be working much harder to get up to that 100% level. And the sooner we can get up to 100%, the better. So that's where we're going to take the test facility. We're going to run it on the 100% hydrogen for as long as we can. And the types of things I'm interested in is, are there going to be any impacts on the assets? Is there going to be any change in our maintenance procedures, our management procedures, anything that we are not aware of that would operate differently in a hydrogen world? And it's only when we've proven it in the offline environment could we ever consider bringing it online at the sorts of levels that we're talking about. Now, there is a little gotcha in all of this. If we wanted to go online at full scale, nobody's producing enough hydrogen yet. So we are going to be filling up our facility by a tanker. It's going to come in probably from Teesside. And hopefully when we get to the sort of rollout stages, we can start looking at much, much larger quantities of hydrogen being available to us, and we can start moving it around the country. Now, where that starts to get to is covered on the next slide. And we've come up with a project here that we've called Project Union. So to put this into context, the current transmission network that moves gas from the tip of Scotland to the tip of Cornwall is around 7,500 kilometres of high pressure gas main. In Project Union, what I'm demonstrating here is to use a subset of that to start carrying hydrogen at 100% quality and 100% blend. Now, in order to unpick about 2,000 kilometres of pipeline from a 7,500 kilometre network is not easy, because we operate today on a resilience level of 99.996. So the chances of you having an outage and losing supply to because a national grid gas transmission asset has failed is minuscule. You know, it's very, very tiny. So we operate on those very high levels of security of service. We've got to figure out how do we migrate some of those pipes to run on hydrogen and then gradually move them across. So Project Union is all about, as it's shown here, joining the dots between the industrial clusters and then building that out in order to start creating a resilient network, start creating a network where we've got some storage. And storage is really important, because when we have those very, very cold days, and we've had a few just recently, the gas network gets heavily used. We carry, but the difference between the gas network just idling along and its peak is around 6 times. You know, so it really has to peak and work hard. And what we do is we actually store gas as what we call line pack. So unlike water, we can actually compress our gas. So we can push more and more and more gas into the pipeline, and then we can draft it back out when we need it. So the UK utilises line pack in order to manage those peaks and troughs, like a reservoir goes up and down over time. It's actually our national transmission network which is doing that heavy lift. It's doing that work for us behind the scenes. So we've got to be able to retain some of that. But again, we're not going to have as much capacity in a hydrogen world. So we're going to have to make use of more storage and work out how do we get gas through the network much, much quicker to be able to get to strategic production locations, and also to strategic stores, and then maybe also to interconnectors. Now, an interconnector is an asset that connects you with another country. And we've got a number of interconnectors in the UK at the moment. And on the next slide, we actually show what the UK could look like in terms of its connections to a hydrogen infrastructure across Europe. And this has just been published literally in the last, I think it was 3 weeks ago now. So this is the European hydrogen backbone, basically demonstrating the potential for a 39,000 kilometre network across Europe, most of it converted. Notice the sorts of numbers we're looking at the bottom. These are some massive numbers, somewhere between 40 and 80 billion to achieve it. What we have to realise is net zero doesn't come free. It doesn't matter. I'm focusing here on hydrogen and what we would need to do in order to decarbonise hydrogen. If you said, okay, we will electrify everything, you are still talking massive numbers to build out the electricity infrastructure. If you recall at the start, I said the gas networks carry 3 times the energy of the electricity networks. So if you want to electrify everything and move all of that energy over to an electricity network, you've got to have 3 times the electricity production. You've got to figure out how much more transmission and distribution, how many more wires and pylons do you need around the country to move that equivalent network. So, you know, an electrification lobby will tell you it's dead easy. What they forget is storage. What they forget is the resilience. What they forget is what happens when the sun doesn't blow and the wind doesn't shine. Well, that's the other way around. The wind doesn't blow and the sun doesn't shine. As we had last month, there were 19 low wind days. 9 days in April were virtually zero. So if you have that sort of stretch, where does your resilience come from? You've either got to be having another energy vector like hydrogen. You've got to be storing that energy, huge batteries, which can you get batteries that last for days and days and days in endless supply? Or you've got to have connections with Europe. Well, if the wind's not blowing on one side of the North Sea, it's probably not blowing on the other. So then you have to start looking at hydro, say from Norway, to bring that electricity in. So we've got interconnectors being constructed from Norway into the UK at the moment. So my electricity colleagues in National Grid are working on that. So these interconnectors are very, very important. So we're going to have to make use of both electricity and gas in a net zero future to make sure we've covered everything. So what does this start to look like? You know, you're not going to be able to go and find a hydrogen boiler tomorrow because they're just not available. They're still in development. So the journey to net zero, we've got mapped out on the next slide, which is a roadmap that my team put together just recently. And this 5-year period we're in at the moment is very much about building the evidence base. It's working out what we can do, how much conversion can you do, how much can be done safely, how would you actually roll this out, can you blend, can you not, you know, how many boilers could you put in, that type of stuff. It's not really until we get to 2025 that you can start to see some things start to scale up. By 25 or 26, we should see some first hydrogen available in large volumes, such that we can start decarbonising the industrial clusters, and we can start scaling demonstrations in the home. And what government want to do is by 2030 actually have a hydrogen town. So we will have selected at least one large scale town and converted that fully to hydrogen to be able to demonstrate it can be done. So we're currently working up what a hydrogen village could look like, a hydrogen neighborhood could look like, and then what a hydrogen town could look like. And it's really when you've only proven all of that that you can start looking at an ultimate rollout. So rollout ultimately has got to start 2030 onwards. Now, that might seem a long way away, but actually 9 years to prove all the safety stuff, to ramp up a supply chain, there's a lot to do. And it's not just us doing it. Bear in mind, all of the countries across Europe are all trying to do the same thing. So there's a lot to do in this 9-year period. So just to wrap up, if you can take me to the final conclusions, please, Phil. It doesn't matter which set of scenarios you look at, whether it's the Committee on Climate Change or National Grid's own FES scenarios, everybody's agreeing hydrogen's got a role. The ultimate question is how much and where do you actually deploy it? We're seeing repurposing being quite possible, quite extensive. We're not spotting any showstoppers right now, which is good. It means we can reutilize the existing assets we've got. In order to get to that point, we've got to collaborate. And as I said at the start, you know, I'm seeing collaboration like nowhere else. I was saying to Phil before we started that I'm doing webinars with Australia, and I've got one with Canada this next week. I was on with the States last week. You know, multiple countries around the world are all trying to collaborate with us because actually, for once, as a UK, we're actually ahead in this space. We are leading the hydrogen agenda, which is fantastic. And ultimately, the catch-all there is National Grid. You know, there's a lot for us to do on the future of gas. So hopefully that was of interest. I've hopefully rounded out and tried to make it relevant to yourselves and not gone too gas techy along the way. So I'll hand back to Hannah at this point, and more than happy to take any questions that you've got for me.
Yeah, that was brilliant. Thank you, Tony. Certainly, I'd heard some things about hydrogen, but you know, it's helped me to put like little pieces of information together to tell more of a comprehensive story. We've had a couple of questions come in. So first one then, considering the big push towards heat pumps in the 10-point plan and the resulting reduced demand for gas, will you need to make room for hydrogen?
That's a good question, because the government has said it wants to start deploying 600,000 heat pumps a year. We currently deploy about 20,000. That is a massive uptick in delivery capacity. Now, where that's going to come from and what that supply chain looks like, nobody really has identified yet. So it's interesting in your question there, you say, will we need to make room for hydrogen? Ultimately, unless that space is filled by heat pumps, there'll be plenty of space there. So my challenge is actually for the heat pump market to step up. Now, it's not as simple as is heat pumps going to solve everything, because 50% of homes in the UK are not very suitable for heat pumps. So it's older properties, single wall, lack of insulation, probably had their water tank taken out to create a bit more room in those rooms. Stuff like that would have to be put back in. Probably new radiators, so you've got larger heat emitters in the home. So actually re-insulating older properties to a standard whereby heat pumps become efficient is actually quite challenging. And actually, as a consumer, what do we want? You know, ultimately, we probably want to be just kept warm, and swapping out a white boiler on the wall today for a white boiler tomorrow that can be done for a quarter to a third of the price is probably what we want. It's the least hassle. Now, there's always people that actually want to super insulate their properties and do everything. But so I think the one thing we forget is consumer choice in all of this. And yeah, I absolutely support heat pumps. There's absolutely a role for those, but we shouldn't forget the people that can't afford the sort of tens of thousands it would cost to actually do some of these properties. So I'll wrap up that question there. Where do you want to go next, Hannah?
That was really, really interesting, because actually, even in my own home, I've thought about this. You know, do I want to invest in a heat pump? Do I want to invest in solar panels? Where's this all going? So what I feel is missing is almost for the sort of the lay people and the general public, actually, the bigger picture, the story, the ability. I guess the recent changes to the grant will have an impact on that, but I feel like there's a lot of uncertainty out there, and maybe not that much. There's lots of information, but maybe not that much that sort of joins all the dots together. So
yeah, I would agree. There's no slam dunk answer in any of this right now, and as a homeowner, it's very difficult to choose which way you would go. There's a couple of areas, though. I think new homes, absolutely, you would go down a heat pump route because they can be built to the standards they need to be built. But therein lies another challenge. Our building standards are not adequate yet, so government need to fix that. The other one to really focus on is actually off-grid properties where you don't have a gas network and people are on electricity already. Heat pumps, figure out how you do that. So I think there's a load of no regret stuff that could be done early on. Yeah. So yeah, I think that's a possible.
Great. Yeah. So we've got another question coming in here saying, Anthony, could you explain the 3 times more electricity needed you suggested near the end of your presentation?
So that's referencing the current the current energy mix in the UK. So if you compare the amount of terawatt hours the gas transmission network carries to the terawatt hours the electricity network carries, it's a 3-to-1 ratio. So gas carries 3/4 of the energy in the UK today. Not many people know that because they see all these electricity pylons and don't realise that there's an infrastructure under the ground that is actually carrying 3 times more.
Okay, thank you. There's quite a few questions here, so I'll
that's all right. Goes fast, and I'll keep my answers short then.
No, that's fine. People are clearly very, very fascinated by what you've presented. So, do you see district heat networks as a viable interim between now and 2050, or a long-term solution to sit alongside hydrogen boilers and the gas network?
Yes, I do. I think district heating is probably an underutilized technology in this country. We do have some heating networks starting to emerge and scaling in certain areas. A lot easier to put in new build scenarios, and if you're building particularly new community housing in city centres and things like that, that absolutely makes sense. Trying to thread a district network through some of our cities would be incredibly challenging. So I think it's another tool in the toolbox, and it should be utilised when and where available, when it's the right thing to do. And you could run that type of system on, say, you could move it on gas now, that could run on hydrogen in the future, and when you've got sufficient electricity, it could be run on a large-scale heat pump in the future. So actually, you kind of future-proof yourself in that type of environment as well.
Okay, thank you. Next one, it says, hi Anthony, is the volume of water produced by the hydrogen boilers significant? And have the water companies agreed that they will accept this additional discharge?
That's an interesting one. So actually, Matthew, I'd almost reverse some of that, because the questions with a lot of people is how much water is actually going to be required to produce the hydrogen in the first place. It is interesting when you start equating the amount of water, because I had a question not too long ago, how much, in order to replace all of the gas in the UK, how much water would you actually need? And it's something like the volume of Loch Ness. It's really significant, but then when you actually equate that into UK rainfall, it's not very much at all. So the water on the other end, most of the water that gets produced by hydrogen boiler just goes off in water vapor. So I'm not aware of the hydrogen boilers actually putting that into the waste network at all. But actually, there's probably no reason why it couldn't be captured and recondensed from a water efficiency point of view, rather than putting it into the atmosphere. Mm-hmm. That's a question I'll have to think about myself, actually. It seems like a missed opportunity.
Yeah, it's interesting.
It's pure water at that point.
Most people would vent my gas boiler vents obviously to the garden. So actually, if there was a way of capturing water and using it to water the garden, that would be a way of circulating that as a resource. Okay.
I'll put that challenge to Worcester Bosch next time I see them.
Okay. Next question then. We've got about 10 minutes left. So, is there waste heat from generation of hydrogen and associated carbon capture analogous to that from electricity generation from steam turbines? And if so, where was that heat going to?
That's a good. I'm not sure I know the answer to that, as in how much heat is produced. There would be waste heat off the steam methane reformation if you're going down the blue route. I'm not sure how much waste heat you're going to get off an electrolyser. So I'm not sure I can answer that question in any credible detail. So I will park that rather than try and mumble my way any further through it.
Another one here. So if hydrogen only has a third of the energy than gas, it will need 3 times as much to provide an equivalent amount of heat to a property. How will that be achieved?
Good question. Some of this starts to net itself out, and you're getting into the mechanics of how the gas could move around the network, because it does have a third of the calorific value, but it's a smaller molecule, so it can actually move quicker in the pipelines. So actually, we don't have the head loss occurring on the pipelines, so we can actually move more of it around. So the two start to net each other out from that point of view. I think the one point that we haven't covered that you've got to remember, in a 2050 scenario, under electricity or gas or whatever else we come up with, there is a big assumption that you've got to reduce, you've got to use less overall. So that should be remembered. So sorry, my dogs are barking at somebody that's just going past my window out here. So ultimately, use less. The networks itself, you can move that hydrogen around.
And on that note, in terms of using less, do you think that would need a public information campaign similar, I guess, to sort of the water efficiency stuff that the water industry currently does? How would you see that happening?
Absolutely. And I think this is the one area that government really need to push. It's a personal responsibility of all of us to use less. And I don't think that registers on the majority overall. And some of that comes down to actually how are the markets set up, because we're in a society where you pay by how much you use, and companies are incentivized to sell more. Well, actually, we need to get to a point where you're actually incentivized to sell less and move less. And that's counterintuitive to the way businesses are incentivized. But actually, from a natural resources point of view, that's where we've got to be.
Yes, definitely. I think we've got time for maybe 2 or 3 more questions. So one of these is, Anthony, with blue hydrogen produced from natural gas, please could you explain how the CO2 byproduct will be captured and how and in what form it will be stored?
Good question. At the moment, it's all being captured, or the proposals are it gets captured as a gas and it's sequestered under the sea in either depleted gas stores or facilities further afield. Now, I think one of the most interesting areas for carbon capture is some of the more innovative techniques that are coming through at the moment. I've seen in recent times a number of bench scale production where they are actually producing carbon in a usable form, either in the use of carbon black. Probably the most exciting one I've seen, though, is capture of carbon as graphene. Now, graphene is a hugely expensive product right now. Actually, if you can produce it, and I did have a company come to me and say, hydrogen is our byproduct overall. Now that starts to get really, really interesting. So I think carbon capture for its big volumes of gas and sequester it is the primary solution right now, but I think we're going to see some others start to come through. But especially when you've got the likes of Jeff Bezos joining the investment campaign for hydrogen. Yeah, it's very interesting. Some of the big players around the world now starting to invest in this space.
Okay, we'll finish off. We've got 2 questions that are along a similar theme relating to the water used to generate hydrogen. So this one says, fantastic presentation, thank you. Do you know how the majority of hydrogen will be generated? Does the water require any kind of treatment prior to the conversion process? So
at the moment, I think we will focus on blue hydrogen. So steam methane reformation, utilise the natural gas reserves, utilise the upstream oil and gas industry that are good at moving that around and do it. There's a secondary industry that I think will grow from green hydrogen and electrolysis that is really going to take off. And I think that's the future. And I use the word, I believe blue is a transitional technology. Now, whether blue is transitional for 20 years, 50 years, I don't know the answer. But I do think it probably sits in that transitional space overall. What was the second part of the question there, Hannah?
Does the water require any kind of treatment prior to the conversion process?
For electrolysis, the answer is yes at the moment, but there are people working on the processes to just be able to work off seawater. And actually that will be a game changer. And a lot of the problems go away, especially in parts of the world where obviously water is a very scarce resource.
That was the question I was coming on to. So you answered them both in one go. So let's see which questions we got left. So I think we can do this one that's just come in, and then I've got one I just want to come back to that's more of a question that's a bit left field. So what is the challenge convincing homeowners to buy a hydrogen boiler when the current message is to change to more electric to stop climate change? And is there an option to buy electric boilers?
So you can buy electric boilers. It will cost you a lot to run them, but you can run your house that way. That's not a problem. I think ultimately it comes down to consumer awareness. And at the moment, what we're seeing is the mainstream media are now starting to get onto this. I'm feeling a little bit overexposed in the sense I've been in the Telegraph, the Times, the Sunday Times, the Independent, all sorts of newspapers in the last few weeks talking about this. And actually what we're seeing are some mainstream, like Sky News had it on last week, 2 weeks ago, sorry, where they actually took you into those hydrogen homes that we showed on the image there. So the mainstream media are starting to get onto the whole journey to net zero. COP26 is obviously going to be a key piece this year to highlight the need, but there's so much work still to be done to get your average consumer interested in caring and wanting to do something about this, because ultimately they're going to either be nudged or forced in that direction. Mm-hmm. You know, that's where it's going to have to go. And no politician likes to force. They want to incentivize and nudge and, you know, get that process moving. Okay,
thank you. So, and then the final question then, and I'm sorry that we've not got, I don't think there are that many questions that are outstanding, but we won't be able to answer all of them today. So is there a plan to use High Street as real homes after the testing is complete?
No. I could say they are livable, but they've been kitted out with IKEA furniture to make them look real. In theory, you could, but no, they're not connected to the sewer network or anything like that. And you're in the middle of a high security RAF base, so I don't think
probably not then. Okay, I think we'll wrap up there. I think there was only 1 or 2 questions we weren't able to answer. Thank you very much, Tony, for your time. I think we had 100. Yeah, thank you. It'd be great if you could come back in a few years' time, maybe, and give us an update on this.
Sure.
It's clearly
More
very
than happy
topical.
to.
Yeah, we had over 100 participants at one stage, so a lot of people are clearly very interested in this. So, and thank you for coming back to the West Midlands branch. Obviously, this is the branch to be, and we're pleased if you've joined us from outside of the West Midlands that you've had a chance to come along to this webinar. And we hope that all of you, whether you're local or further afield, will attend our future programme of webinars as well. Okay, well, I think that we'll draw it to a close there then, unless there's anything further we need to add, Barbara, from a HQ perspective.